Hey, welcome back. So in today's video, we're going to talk about clusters. So let's get started. First thing first, what is clusters? So clusters are group data elements of mixed types. So they can be strings, they can be numeric, they can be Boolean, and they are handy to use when you want to structure your data into manageable package. So assume you have like different kinds of data. You have numeric, strings, Boolean, and so on. And then you want to have them in one package. So you will have like a cleaner space for your program. You can use clusters. Clusters are generally used to group related data elements that appear in multiple places on the block diagram. By related, I don't mean the same type, but related means they do the same thing in your program. Because a cluster is represented by only one wire in the block diagram, its use has the positive effect of reducing wire clutter and the number of connector terminals needed by sub-VIs. So basically when you use a cluster, instead of like having too many different types of data to wire them together with different functions and so on, you can define one cluster, like one box that you can connect everything to it, and it will be your space will look cleaner. So you can decide to use clusters based on your applications. It's not necessary to use it, but it's something that is good to know. So whenever you have a program and you're building your program and you feel like you can use clusters and make your program cleaner, you can do that. But it's not absolutely necessary. It's just something that it will look nicer. So now let's get started. So open a new VI. And in the new VI, we'll go to the front panel first, right click, and go to Array, Matrix, and Clusters. And then choose a cluster, and then put it here. So basically, it will open a box for you. And then that box is also showing here as a function. And you can see this cluster here is a control. It's sending signals out, so it's a control. So let's define this cluster as name it as book. So basically what I want to do is that I want to have a cluster defined as book, and I want to give a title, an author, which they are all strings because they are words, and a year, which is a numeric, and I'm going to add some Boolean to it. So right click and go to the string and choose a string control here, and then name it title and make it larger, and do the same thing again, string control, author or authors or whatever, and then next time we're gonna go to numeric and choose a numeric control. And that's going to be the year. Assume I have a Boolean with like, I don't know, like a push button, whatever. And is it for sale? So we want to see if this item is for sale. So now I have a mix of strings, a numeric, and a Boolean. So basically you have defined your clusters as a mix of items. So assume that now you have these clusters that gets all this information, but then you want the user to only see the author or only see the title. So you want to unbundle it. So basically this is all bundled, and you want to unbundle it to have different components of these clusters. You go to the block diagram, you right click, go to clusters, class, and variant. And here we have different things. We have like unbundle by name or bundle by name, unbundle, and bundle. So bundle basically gets everything together into one cluster, and unbundle basically unbundle it and gets the components of the clusters. You're gonna choose the unbundle by name for now, and then put it here. And because this is a control, this cluster is a control, you can connect this to here, and you you can see what once you connected it, you will see the first thing, which is a title, shows up here. You can take it down to author, year, and then you can see the is it for sale is just going to be repeated. So that means that that's the end of your clusters. And then now if you right click on the title part and go to create an indicator, you will create an indicator for title here. Let me make it larger. You can do the same thing, create an indicator for the other elements of author, year, and the Boolean function, which is basically a true or false. So you can create an indicator for all of them. You can always make them like nicer and cleaner like this and have them show. So something like that. So I have the author here. As I said, once you move something in the block diagram, it won't necessarily move in the front panel also, and vice versa. So you have to move things and make them cleaner your way. So let's save this program and cluster 101, something like that. And so now let's run this program. So say the title is I don't know, LabView class, something like that. Title of the book. The author, say it's me. The year is like 2019. And is this book for sale? You say yes. And now let's run it. You can see that now I have like kind of unbundled all of this title into different indicators. So then you can use this indicator for your future programming and use it. So this way, instead of like defining like if I want to do it the other way without cluster, I would come here. I would come here and choose a numeric control, put it here, and then call it I don't know, like title 2, something like that. So it won't be confused with the other one. And then we have to choose another numeric, and then I would call it like oh no, not the numeric, sorry, this is the year. I made a mistake. So year 2, and then another numeric, we need a string. I will come to the string and go to the string control and then call it the title, and then title 2. And then I'll choose another string and then call it author 2, something like that. And then I have to add a Boolean also here and say, is it for sale 2, something like that. And then you have to, like, if I want to do it the other way without the cluster effect, you have to create an indicator for all of them separately. You can see like that. It's gonna get really cluttered here. Cluttered here. So yeah, something like that. And then I think this is this. I think this is this. This is this. And the author is here. Something like that. And then like whatever I type here, I don't know, whatever. When I run, it's gonna be shown in the indicators too. So instead of like having something like that, which is gonna be cluttered, you can have it like cleaner into one item. I'm gonna delete all these because it's just not necessary for now. So basically the cluster, it's gonna do this. It's gonna clean your space, and the good thing about cluster is that you can have different kinds and types of controls and indicator into one item. So that was basically unbundled by name. We have another one which is just called unbundle alone. So if I choose this, and then if I see, I want to show you something else actually. Say you want to replace unbundle by name by unbundle. You can click on the function, which is the unbundle by name, and then go right click and go to replace. And in the replace, you can either go to all the palettes or go to the specific palette that the unbundle by name was from. And that's the cluster class and variant palette. And then you can choose unbundle. And this way, it's way easier than deleting the previous unbundle by name function and delete all the wires and do the rewiring thing. So I want to show you this. Unbundle by name gave you the title, author, year, and is it for sale or not. So it's really easy for you to see, okay, what each one of these components of the cluster is. But unbundle doesn't do that. Unbundle only organize your items in your cluster based on the type of that item. So for example, here it only organizes it by like strings. So you can see it's pink. It says ABC pink, and then it's written DBL or double precision point, something like that. And it's like orange, and then true and false, which is for the Boolean function. Okay, so that was this part, and now let's say about something else. Okay, so you can, like, the orders of the clusters here are like title, author, year, and the Boolean function here. You can change the order of them by clicking here on the front panel on the cluster, because your cluster is a control. So you can click on the front panel and then right click and go to the reorder controls in cluster. And you can see there's like 0, 1, 2, 3. You can change their order by clicking on them. And for example, changing this to 1, this 0, and this 2, and this 3. Or you can change this to like different numbers, like whatever way that you want them to be. And then after you're done, you can click on confirm. And now you can see, now it's different. Here you can see some wires are wrong because now the second one is the DBL, or it's the numeric, and shouldn't be connected to an author. So one thing you can do, which I think is better, is that click again here and then replace this with the unbundle by name, because this way it's easier for you to see which one is which. And then you can delete whatever wires that are wrong and do the rewiring again, and just wire the orange to the orange, the author to the string, and all these things, and it should be fine now. And if you run it again, everything is fine. So that was unbundle. We have a bundle too. Like if you have different controls and you want to bundle them all into one indicator instead of having like a ton of indicators. So this way, I want to show it the other way. I want to do it the other way around. I'm gonna delete this one, and I'm gonna delete all the wires here, because I want to show you another way that you can do this. So select all the indicators here and align them. So something like that. Now, if you select them all and then go right click, you can say, these are now, they are all indicators, right? So you can change them to control. So basically, instead of like being an indicator to receive signals, they will be changed to control, that they will send signals out. So now they are all controls. I will align them, make them look nice. And I have this cluster 2, which is a control 2, but now you want your clusters to be an indicator because you want to bundle all your controls into one cluster as an indicator. So again, you can right click and say change it to indicator. So now your cluster is an indicator. You can see that now these are white. That means that they are controls, and these are gray. That means this is an indicator. And then you can move things around. I usually like to have controls on the left and the indicator on the right so that the wire is just one straight line. And now if you right click on the block diagram, go to cluster, and this time choose either bundle by name or just bundle. I'm gonna go with bundle by name. So now you have to wire this bundle by name to your clusters and your control. First thing that you need to do is to define what kind of cluster this bundle should read. Like should it read like titles, authors? Are they strings? Are they numbers? Like you need to know. So your first thing that you need to do is to right click on your book, which is your cluster indicator, and then create a constant for it. This way you have all the information of what kind of cluster we are having. And because I've already reordered things, these are reordered. We might have any orders, it doesn't matter. So, and then we can delete this wire. So this shows that our cluster has like 2 strings, 1 number, and 1 Boolean function. Then you in your bundle by name, there's a part which is called input cluster. You can wire this to your constant, and now you have defined your cluster. And because it's bundled by name, it has all the names. So now you know that we are having title, year, is it for sale or not, and author. So now you can wire all your controls to the appropriate point, and then you can also wire your output cluster to your book. So this way is another way around. You basically create controls, so your program has different kind of controls, and for your indicator you don't want to have like a ton of different indicators showing there, but you basically just need to have a cluster. And so your block diagram looks cleaner. Instead of like having like 4 different indicators here, you just have only one cluster as a book, but in your front panel your book shows all the information and all the details there. So now because this is the control, let's type like different names here, something like that, and now let's run it, and you can see like this has been updated. I couldn't type -2 because this is not a string, so it should be a number. So I changed it to 2018, and you can see how it changed. So basically clusters are used to clean up your block diagram and have it have your program look easier to follow and easier for you to understand also. You can either bundle and create have a different kind of controls and bundle them together to have a cluster as an output as your indicator, or you can unbundle. If you have a cluster as your control, you can unbundle it to have different indicators. So that's what I wanted to show you about cluster. There are so many different things that a cluster can do, but if I want to go over all of them, we don't have time for the other things that I want to teach you in LabView. But I think this is something that is basic and you need to know. So when you're reading other people's code, or if you're Googling online for different things, you can see how a cluster works and understand it better. So next thing for the cluster, I want to talk about the cluster errors and the errors. So I'm going to save this, and then I'm going to delete this part, and I'm going to save a new one. And I'm going to, basically what I'm going to talk about is about write and read from Excel. So what I'm going to talk to you about is that I'm going to show you about I'm going to show you error clusters, and at the same time, while introducing the error clusters, I want to show you how to read and write from an Excel sheet, which is really useful. Sometimes when you run your code and you have your data acquisition system and you are saving all your data in your LabView program as an array or a matrix, you sometimes, I guess, most of the time, you need to save your data into an Excel file in your computer too. So several days later, you can go back and look what data was printed and how your system actually worked. So it's usually towards the end of your program, you need to either read or write. Towards the end of the program, you need to write data to an Excel, and maybe from the beginning of your program, you need to read something from your previous data. So there might be a lot of different things that you want to do with this, which I thought it will be really important and necessary for you to know how to do this. So if you, so first thing, let's open an Excel file and create an Excel that we want to, for the first time, for the first section, I want to read the Excel file. So let's open an Excel file and create just type some data. Like I would type 101 and then 15, 2, 1, 2, 3, I don't know, like 3, 4, 5, 6, something like that. So assume that these are the data that the LabView wants to read. You can type whatever you want, but they have to be like numbers, right? I will show you what I mean later. So save it as a .csv file, not an Excel, CSV file. So it's basically like a text file. So save it in your computer. I have a folder for the class that I save everything there. So I'm gonna call it data 2 because my data 1 was for my MATLAB program, if you remember. And then as I said, save it as a .csv file. And then save it. Okay, it's saved now. And if you go to the block diagram, right click in the block diagram and go to the file I/O. And there's two things, write delimited and then read delimited. We want to read the Excel file, so we're going to choose the read first. And if I right click and go to help, it will show you what each of these like nodes on these functions are. So the green node is the file path of where your Excel file is saved. And the format, I always go with %F so that this will get all the numbers there. And it will ask you from like number of rows that you want to read. Do you want to go all the rows or just some of the rows? Something like that. And then it's here it will ask you, do you want to transpose whatever you read? And here it's going to show you like either all the rows or just the first row of the Excel file that it's going to read. And if you look in here, like the yellowish black thing, it's the error in and the error out. These are the error clusters. So whenever you have a function in LabView that has the error nodes in it, it is really useful to wire the error nodes. It's not necessary. You will not have an error while running the program. You can run the program. But in case your program gets to an error, there will be a pop-up message on your screen, and then you have to be there to manually click on it, either stop it or continue it. But if you have the error in and error out, the arrows will be out and it will be shown in your front panel as a cluster of an indicator, and then you can see that error and it will not necessarily stop your program. So it's better to always wire all the errors. This way your program will continue and it will not stop in a point, because you know all these wires that are coming into a function and getting out, if there is an error here, it will stop. It will not get out. But if you wire the error clusters, if you wire this the yellowish black thing out, it will send the error to the next function, and your program will continue till the end until the error really stops it. But if you don't have this error wired, then your program stops right in here because it cannot continue, because it has an error inside of it. So I really recommend when you're working with functions and you see error clusters, always wire them to the next function and get the error out. Don't let it sit there. So first thing, we have to connect, like wire all the things and all the nodes on the left sides, because these are like the controls that will send the signals to it. So right click and go to create control for the file path, so which is the green node over there. So here you can basically go to the folder where you saved your data, my data 2. I can go there and tell, okay, this is data2.csv. So you can tell the program where to basically find the Excel sheet or the text that you have. And next thing I want to do is that I want to right click on the format and then create a constant. It always shows a %3f. I usually delete that and just have it %f. So if you have it %f, it gets all the numbers out. And if you use %d, it will change your real number into an integer. I can show you what I mean later. And then on the right side, you have create an indicator for all the rows. So you want to show you want to see all the rows. For the first row, we won't do it right now. I want to show you what I mean later. But this is for all the rows. And then we have the arrow clusters. You can say create for the output. Stay and say create an indicator. So if we have an error here, it will show the error for us. We don't have any error getting in because prior to this read delimited function, we haven't had any other function that will send errors. But if before that we are doing some other things, that function has some error out clusters, you can wire that error out clusters to the error in cluster of this function, and this error out can go to the another function as an error in. So something like that. But for now I'm gonna do this, and I'm gonna move things around a little so it's cleaner. Okay. Okay, so there is another thing that needs to be done before running this program, and it's here. Like if I go to the help, it's this part, the delimiter. So if you choose a comma, you basically change one column to the other column, and you will go to different columns for different rows. But if you choose \t, it will just add a space. And it is always \t here unless you change it to a comma. So here we have to change this string function here, create a constant for it, and change it to comma. So this way it will know that it has to go to the next column. So now let's run this. So you can see after I run this, the Excel that we have created here, this Excel is now showing all the data here for us. So I wanted to show you like what I meant by sending the signals out to the next one and to the next one. So let's get started on that. So say that you have read this Excel file, and now you want to write this Excel file into another Excel, call it like data3.csv, something like that. So you go to the block diagram, you right click and go to the file, and in this time you choose the right delimited function. Sorry. And in the right delimited function, you basically want to read all your array here that you have generated. I'm not going to make another array here, but just say that the array that you have generated in your previous program. So for example, you have built a LabView program that is reading signals from a data acquisition system, and the signals meaning the voltage, the temperature, the current, the pH, whatever that you are reading. you are reading that and you're saving your data into an array, which in the next video we're going to talk about arrays. So you're saving your data into an array, and you want now to write all the data, all the information that you have saved in your LabView program in an Excel file, and you want to save it in your computer. So you choose the write delimited function, and what this write delimited function needs is that it needs the data, either a 2-dimension data or 1D dimension data. Here our array is a 2-dimension. You can see 1, 2, we have rows and columns. So you can, like if I click on it, I will go to the first row, to the second row, and all this, like the first column or like the 0 column, like all these things. So the rows and columns. And then so R is a 2D, we have 2-dimension. So either a 2D or a 1D. So because it's a 2D, I'm gonna wire the 2D to the rows here. And notice that a 2D has like 2 orange lines instead of just 1 line. So that means that's a 2-dimension. Like here, this is like 1 line, it's only 1 dimension. If it was only 1D array, it would only be 1 line. But because it's a 2D array, it's 2 lines. It is actually asking for a file path that you want to save your data, like your Excel file in it. So you have to define like where do you want to save it and what kind of name we want to give to it. So you'll say create a control, and here you'll have a control. I have to move it down. Okay, so, and I'm gonna save this as data 3. So I'm gonna rename this file path so it won't confuse you. This is for reading, and this is for write. So basically data 2, we have saved it you have it in Excel, and we want the LabView to read it, and we have generated this code to read it, and now we want to write whatever that we have read into another file, and we're going to call it data3.csv. So yes, it's going to ask for the file path. It's going to ask for like what kind of, like what is the information that you want to write in. So your array of the data that you have. Again, here you have to define the delimiter as a comma. Just make sure that you always use a comma, so it will go to the other columns and fill the entire thing. Now this is what I want to show you, the error in. So the error in that gets into your write delimiter is the error out here, right? So assume that you are having like 2 different functions running, and you can wire all the error out from the first function into the error in of the next function, and the error out of that function to the error in of the other function following that function. So basically, if you wire all the errors out, you only will have like, you will only have like all the errors out, and you will only have the error towards the, if you have an error, you will have the error towards the end of your program, so it won't stop your program. So now let's run this and see like how we will save, now let me delete this because I have practiced it before. So now let's see how we will save a data3 here once we have run this program. So we are reading data2, and then we're going to write it into data3. See, I have data3, and if I open it, it's the same thing as data2 that we have created. So now let's show you the error out, the error clusters. So here you can see we have like a status which is green checked. We don't have any code number, and we don't have any text defining the error. So say that you mistakenly, instead of saving it as .csv, you have saved it as .xlsx, and now you want to run it. see there is an error. Error number 7 occurred, but you can see that the error occurred towards the end. I will show you once I turn on the highlighting here. And now if I click on stop, it will stop the program. It says that the status is red and we have a code 7, and it says that it cannot open the file because this is like a text file. It has to be a CSV. It cannot be an XLSX file. So the error cluster basically show us like what is the code number, which is a numeric, what is the source, which is some text file, and the status, which is like a Boolean function, true or false. So we have different kinds of indicators that are showing into one cluster for us. So let's say that, let's turn on the highlighting, and then I will run it again with the same error. So there was an error here. You can see that the error 7 generated at first, like initially, but it started sending signals out to the other. So it kind of like finished the program, and towards the end, it will show you the pop-up error and the error in the clusters too. And if I say continue, it will continue or it will stop. So now let's say that if I don't have these error clusters, like if I forgot to wire this thing and I don't have this error cluster. Now, let me delete this one too. So I just didn't do anything with the error clusters. Now if I run this, let's have the highlight on too. The error happens, and then we have this error also showing here to stop it. So we have to basically we have to wait for this error to pop up to show us what the error is. But if you have the error cluster from the beginning, once it's there, you will see what the error is, and you can stop the program like towards the beginning of the program. So now let's have these errors out, and I will define an indicator for the error too. So we have the cluster here. So it's really good to wire all the errors. It will help you a lot during a program. This program is not big, so it will not, I cannot really show you what I mean with the errors showing. But when your program is big in your lab, when you're creating a program and you have a big program, if you don't wire the error clusters, if you don't wire the error in and error out of the functions, your program stop earlier than and it will stop your program. But if you have them like if you wire them all, then you have your program running, and you can see the errors, and you can see the error, like what is the error, and you can stop the program before continuing more. So it's really helpful. So now let's say sorry, this video is gonna get a little bit longer, but just one more thing that I want to show you with this read and write, because I think it will be really useful for you, and then we will be done with this video. Say that your Excel file here, like go to the first row and insert another row and define an X and Y. So you have labels in your Excel file, and then let's save it. So now you have like numbers and text. Like how we do this part, we can define a structure, a case structure, and a case structure is a true or false. And then here on the front panel, you can define a Boolean, and in the Boolean you can say, do you have labels for your columns? And if you have labels for your columns, then this will be on, and then we also need to wire this to the case selector, so that defines the true and false we have. So if this is true, that means that I have a label, and then I can I can divide my Excel file into two things: the first row, the labels, and the other rows, which are just the numbers. This way you also have like what each of these columns actually they mean. If you remember from previous videos, sometimes you need to use the same control at different locations, and you don't want to have a lot of wires. So you stay on that control, you go to create, property node, and you go to value. and you will have the same control here in the block diagram without producing another one in the front panel. This way you will have like a cleaner, basically program. I was like thinking in my head that I can make a cluster out of it too, but let's just go it this way. And then I'll just, this is for read, so I'll just Control C and Control V the same function, which is for reading. And you can see here I have either like double, integer, or string. Choose the string here for now. And then wire this to the file path that we have. And here, if you remember, we had all rows or first row. Go to the first row and then create an indicator. So basically, this is only reading the first row of your Excel file. And again, here choose a comma for your delimiter. And the format here, it's a %s because this is like a string, it's not a number. Now if my God, I want to move this. Double click here and then move it. So now I have my first row here. So now if I run this program, you can see that I have the X and Y here as the first row for my program. But here for the all rows, it basically created 0 for me because it cannot read the X and Y, so it generated 0. If you want to get this row out, on the next video, we're going to talk about arrays and how to subtract arrays and get a subset of an array and all these things. And you will learn how to do that. But for now, because we are not talking about arrays, I'm going to stop the video here and just wrap it up. So we talk about clusters and how useful they can get in our project. And I also talked about the error clusters, which is really important, and how to read and write from an Excel sheet. I hope you guys enjoyed this video. Till next video. Bye.